In this video lecture, we will discuss about structural isomerism. First of all, let's define isomers. Isomers are the compounds having similar molecular formula but different structures. For example, first compound is ethyl alcohol and second compound is dimethyl ether. Molecular formula of both the compound is same, that is C2H6O, but the structure is different. First is alcohol and second is ether. So the compounds having similar molecular formula but different structures are called as isomers. Isomers or isomerism is of two types: structural isomers and stereoisomers. Stereoisomers are of two types: optical isomers and geometrical isomers, whereas structural isomers are of following type: chain isomers, position isomer, functional isomer, metamers, tautomers, and ring chain isomers. In this lecture, we will discuss about structural isomers only. So let's start. First, structural isomers are chain isomers. So they can be defined as: these are the compound which possess similar molecular formula but differ in number of carbon atom in parent chain. So their molecular formula is same but the number of carbon in parent chain is different. As we are seeing, in first compound, parent chain possess 4 carbon. In second compound, parent chain possess 3 carbon. So we can identify chain isomers by difference in their word root. For first compound, word root is but, and for second compound, word root is prop. So chain isomers differ in word root. In alkene, chain isomerism starts from butane. Now if the question is how many chain isomers are present for pentane, so we can understand first isomer possess 5 carbon in parent chain, second possess 4 carbon, and third isomer possess 3 carbon in parent chain. All these isomers are differ in word root. For first, word root is pent, for second, but, and for third, word root is prop. Second structural isomerism is position isomerism. Position isomers are those compounds which possess similar molecular formula but differ in position of substituent, multiple bond, or functional group. So remember, they differ in position numbers. For example, in first molecule, the name of compound is 1-chloropropane, and in second it is 2-chloropropane. Since word root is same, so they are not chain isomer, but the position number of substituent is different. In first case it is 1-chloro, in second case it is 2-chloro, so they are the position isomers. Similarly, in case of but-1-ene and but-2-ene, we can understand difference in position number. Now third type of structural isomerism is functional isomerism. Functional isomers are those compounds which possess similar molecular formula but differ in types of functional group. They differ in suffix except amines. For example, in first compound, functional group is OH, that is alcohol. If we shift CH2 towards other side, the compound formed will be ether. So functional isomer of alcohol is ether. Similarly, for aldehyde, after shifting CH2 towards right hand side, we get ketone. So functional isomer of aldehyde is ketone. Similarly, for cyanide, functional isomer is isocyanide. For nitroalkane, functional isomer is alkyl nitrite. For amines, the functional isomers are as number 1, number 2 and number 3, that is primary amine, secondary amine and tertiary amine. Now the next type of structural isomerism is metamerism, or metamers may be defined as these are those compounds which possess similar molecular formula but differ in distribution of carbon around functional group. Means in this case, functional group remains same, but the number of carbon around functional group gets changed. For example, in this first case, we have 2 carbon left hand side and 2 carbon right hand side. Now, in second compound, we have 3 carbon left hand side and 1 carbon right hand side. So both the compound possess similar molecular formula, similar functional group, but they differ in number of carbon around functional group. Similarly, in case of amine, we can see the number of carbon towards left hand side are 3, toward right hand side they are 2, and in second compound the distribution of carbon is 4:1, 4 carbon left hand side and 1 carbon right hand side. Now always remember, 2 compounds can show more than one type of isomerism simultaneously. For example, in these 2 cases, we can see in first case both the compound show metamerism because they possess different distribution of carbon around the functional group, and they are also chain isomer because in first case parent chain is of 3 carbon, in second case it is of 2 carbon. So 2 compounds possess 2 types of isomers or isomerism, metamerism and chain isomerism. Similarly, for second case, they are metamers because they differ in distribution of carbon around the functional group. They are also position isomers because you can understand their position isomerism nature by their name. First compound is pentane 2-on and second compound is pentane 3-on. So they show metamerism as well as position isomerism. Tautomerism. It may be defined as migration of hydrogen across the multiple bond. Tautomerism is also known by some another name. For example, desmotropism, dynamic isomerism, cryptomerism, etc. It is of two types. Number 1, dyad system. Number 2, a triad system. The most common is a triad system. First of all, dyad system. It involves 1-2 migration of proton or hydrogen from one polyvalent atom to another polyvalent atom across multiple bonds. So we can say this involves 1-2 migration of hydrogen. Hydrogen shifts from one atom to second atom. Now the next and important type of tautomerism is triad system. It involves 1-3 migration of hydrogen. It is of following type. In first case, acetone. So hydrogen from alpha carbon migrates on oxygen across the multiple bond. So we can say it is 1-3 shifting. Hydrogen from first atom migrates to the third atom across multiple bond. First form is called as keto form and second form is called as enolic form. So that is why it is also known as keto-enol isomerism. Nitro, Ac-nitro, for example, it is a nitromethane or nitro compound. Hydrogen from first carbon migrates on the third atom oxygen across multiple bond to form Ac-nitro form. So first form is nitro and the second form is Ac-nitro.